Assalamu alaikum. Welcome to the lecture 4 of Unit 2nd. Today I am going to teach you analysis of half-wave uncontrolled rectifier for active loads. Here the load has its own EMF. What is this active load? This active load is that load which can supply energy back to the source. This is a simple circuit diagram of a single phase half wave uncontrolled rectifier for RE load, where we have EMF at the load side. These are the waveforms for source voltage, load voltage, output current, and the voltage across the diode. Here, the EMF source is represented by a continuous DC source shown by this dotted line, and this source voltage Vs is a sinusoidal voltage, and its wave shape is like this, having positive and negative cycles. We are dividing this 0 to pi interval into three parts. One is 0 to theta, another is theta to pi minus theta. That means one is from 0 to theta, another is from this theta to theta pi minus theta, and this one, a third one, is from pi minus theta to pi. That means from 0 to theta, this diode is not conducting as the source voltage is less than EMF. Then from theta to pi minus theta, the Vs is greater than E, or we can say diode is forward biased, and from pi minus theta to this pi, this diode is again reverse bias, as the source voltage is less than this load voltage. Since from 0 to theta, diode is not conducting. If diode is not conducting, that means there will be no current. That means this is open circuit. There will be no current I naught, and accordingly the voltage V naught across this RE load will be equal to this EMF, because this is open circuit. If the voltage across this load is represented by V naught, that means this V naught is equal to E, and I am representing it here. That means from 0 to theta, this V output will be equal to E, as no current flow, as the diode is reverse biased and no current is flowing in this circuit. Now, when this diode is forward biased, that means from theta to pi minus theta, the output voltage will be equal to Vs. Peak of this voltage will be exactly at the same peak, that means at pi by 2. That is the peak of the source voltage. From pi minus theta to this pi, the diode is reverse bias. If diode is reverse bias, that means no current will flow in the circuit. If no current will flow in the circuit, this output voltage will exactly follow that output voltage will be equal to this load voltage, that is E. Again, I am representing this by E. From pi to 2 pi, again this diode is reverse biased, or we can say the output voltage will continue to remain at this E, until again at this 2 pi plus theta, again this diode is reverse biased. That means from 2 pi plus theta to this 3 pi minus theta, this diode is again forward biased, and the output voltage will be equal to Vs. Again from 3 pi minus theta to this 4 pi, the diode is reverse biased, or we can say the output voltage will remain at that E. Since diode is conducting only from theta to pi minus theta, or we can say from 2 pi plus theta to 3 pi minus theta, that means the current will flow from this interval to this interval, and this interval to this interval. The value of the current will be equal to that is Vs minus E divided by R. If this is the source voltage minus E, that's why I am showing here only the peaks. That means this remaining peak and this remaining peak. Maximum current will be exactly at omega t is equal to pi by 2, and here as well as in the next cycle. Now, what will be the voltage across the diode? Diode conducts only from this interval to this interval, and from this interval to this interval. That means the voltage across diode during this interval will be 0. Since we know that from 0 to theta, the diode is also reverse bias. As diode is reverse bias, we can say at this zero crossing, since the source voltage is 0, we can say the voltage across this diode becomes equal to minus E, or after zero crossing, the source voltage starts building up. Voltage across diode goes on decreasing until at this point when the source voltage becomes equal to the voltage when the source voltage becomes equal to the EMF source, the diode starts conducting. Similarly, from this interval again, that means pi minus theta, the diode is reverse biased. The peak of this reverse voltage is at the peak of this reverse voltage is minus Vm minus E, or I can write it as minus bracket of Vm plus E. This is the peak inverse voltage. Again, until at this interval, that means at this 2 pi, if I am showing this by another color, until at this interval, that's omega t is equal to 2 pi. Until at this omega t is equal to 2 pi, that means again the next cycle zero crossing starts. That means again at this interval, that means at this 2 pi interval, the voltage across this diode is equal to EMF source E. That means this is again until again it starts decreasing till at 2 pi plus theta, the diode again becomes forward biased. Same I am showing here by the calculations. That means from 0 to theta, this Vs is equal to, Vs is less than E, or we can say diode is reverse bias, output voltage becomes equal to 0, output voltage becomes equal to E, and I naught is equal to 0. Similarly, from theta to pi minus theta, Vs is greater than E, or we can say diode is forward bias, and the output voltage will be equal to voltage across the resistor plus that battery EMF, or we can say I naught is equal to V naught minus E divided by R. Again, from pi minus theta to pi, Vs is less than E, or we can say diode is reverse biased, or I naught is equal to 0, and V naught again is equal to E naught. From pi to 2 pi, as diode is again reverse biased, or we can say I naught is equal to 0 and V naught is equal to E naught. The voltage across diode will be equal to Vs minus V naught, that is equal to Vs minus E. Now, from this diagram, calculate that the peak inverse voltage is equal to minus Vm minus E. And the conduction period is from pi minus theta to this theta, or we can say the period is pi minus theta minus theta. That's equal to pi minus 2 theta. The peak value of the current is at omega t is equal to pi by 2, since resistive load. This I naught average will be equal to, since the interval for which this is conducting is from theta to pi minus theta. That's why, and this is the value of current, that is Vm sine of omega t minus E. This is the value of I naught average. V naught average will be I naught average into R plus E, and this is the power factor that that we have calculated, and this is the RMS value. Since the RMS value 1 by 2 pi, this is 0 to theta, the output voltage is equal to E. And for theta to pi minus theta, output voltage is equal to Vm sine of omega t, and from pi minus theta to 2 pi, again the output voltage is equal to E. This is the RMS value of the current. This is I naught RMS, that is V naught RMS minus E divided by R.